Hello, it is Wednesday, March 24th, 2021. So today we're going to be continuing the stuff that we were doing yesterday. So let me get rid of that because we don't need it anymore. And then let me open this version of Unity as soon as Unity wants to cooperate with me. Okay. It looks like the camera is actually working today, or the green screen at least. It's weird because it's a cloudy day, so that's not normal. Well, it's not normal for the camera to work so well on a cloudy day. But anyway. Hey Omar, how's it going? I hope the stuff yesterday was informative. I don't know, I hope it was. I tried to go through it as best I could. Oh, that's interesting. So I never noticed this little thing you can, oh, whoa, that's very strange, okay. That's very weird how they have that. Oh wow, you can click, oh that's cool, I didn't know you could do that. Okay. But yeah, yesterday we were working on this, it's a clone of a game called Grand Magus that was made for the Scorespace Jam, I believe? Yeah, Scorespace Jam 12. Anyway, it's basically you have enemies that spawn and you try to shoot them before they hit you and kill you. So yeah, yesterday we got the movement, enemy following and shooting down. So one thing I noticed is that the projectiles can actually collide with themselves. I had not thought that through, but apparently that's a thing. It's kind of easy to deal with that problem though. So yeah, I think whenever we left off yesterday, I don't remember what we were going to do. But yeah, we were going to add health and stuff and make them actually, make things actually die. So the way that we're going to do that is we're going to add a C# component. It's going to be a health component. Hey Gaffa, hey W. Someone's going to say, yeah, I don't know how you pronounce your name still. I'm just going to still call you W. So it's evening for you? What part of the world are you in? Is it Europe or is it, we're evening right now. Oh, in Sweden, okay. Well, that's cool. I don't know, how's life in Sweden going? I haven't really been keeping up with it much with Swedish or not with Sweden, but I haven't been keeping up with what's going on in Sweden. You know, 2020 for the US was kind of enough to occupy everyone's minds. So, what we want to do, the reason that we want a health component, so I should probably explain that part. Because we want things to die. Oh, it's 9 p.m. for you. I forgot, where are you, Omar? I apologize, I didn't know it was so late for you. I would have done this earlier if I had known that. So yeah, I might have to try to stream. I might have to stream at like an hour earlier or something then. I don't know. But yeah, apologies, I didn't know it was so late. Oh, Pakistan, oh wow. That's crazy. I hope all is well over there. Yeah. Okay, so yeah, I'd say it's pretty good. Sure could be better. People follow it. Yeah, people have been, yeah, even over here, like I live in Texas and they just said, well, we're just gonna stop the recommendations. You know, the government isn't even recommending things anymore for us. I think they either gave up or they just kind of decided it didn't matter. It's crazy. I was at an event yesterday. There were like 300 people there packed into like a ballroom and nobody had a mask on. It was pretty crazy. But you know, it is what it is. I've actually had the virus, not from last night, but months ago I had it, and I'm not afraid of it anymore because I've had it, so I don't think there's going to be an issue with it. But you know. Yeah, so so what we need to have something that tracks the health of the player and the health of the actual enemy. For convenience, I'm going to pack it into the same script, because when it reaches 0, they both do the same thing. You know, the character dies. So that's why I'm going to use a health component. And so we're going to call it that. And then we are going to have a method for it to say, take damage. It's kind of a public void take damage. and then we're going to make it public so that other scripts can call it. We're going to give it an integer amount. And then what we're going to want to do is we're going to track the current health and then the, well, actually just the current, well, I don't know that you can heal in Grand Vegas. So yeah, I'll just say we're going to track the current health. Well, actually, it should probably be public. And say public int health. Health? Yeah. And so in C#, yeah, in C#, if you want something that only this, well, actually, no, never mind. We're going to need to make this public anyway. So yeah, we'll just say public health, and we'll make sure that it's equal to, let's say, at least 1. And so what we want to do is when we take damage, we want to say that the health is minus equal to the amount. Minus equals is basically the same as saying equals health minus amount. So that you can basically just pack the two into one. So if I wanted to do this, you know, health is equal to health minus amount, and it'll tell us, hey, you can use a compound assignment. And so then what we want to say is we want to say if health is less than, let's say, 0, or less than or equal to 0, then what we want to do is we want to say public void die. So that's what happens when something dies. We're just called die. And we also want to make sure things can't die twice, because that can be an issue. So we'll just create a protected boolean, and we'll say is dead. Normally for booleans you have, well, actually we'll just say dead. Dead. We will, whenever we click die, we will say if we're already dead, then we just return. Otherwise, we actually set dead equal to true. So dead is equal to true. And then in this case, we're just going to destroy the game object. So that's destroy ourselves. And so what we need to do before this will work with the projectiles is in here, I say on trigger enter. In the on trigger enter, so this is called whenever the projectile hits something, and this is the object that it hits. What we'll say is var, not var, we'll just say health component. This is the health. It's equal to other.get component. Well, can you not do? Yeah, you can, okay. We'll say health component. So what this will do is this will get the health component for the other, for whatever this collides with. And what we want to do is we want to say that if the other thing doesn't have any health, then it makes no sense to do any damage to it. So we'll say if not health, then we kind of just want to return. Well, yeah, this will deal with some things, but not others. Then I think it'll stop working whenever it hits the walls, but we'll deal with that later. So if there's no health, then we return. Otherwise, we say health dot take damage, and then we will say, I don't know, it takes 1 damage. So everything has 1 health at the moment, so they should just kill things in 1 hit. Projectiles should no longer be destroyed by the walls, but they will also end up being destroyed by the enemies. So let's just test that a little bit. Actually, before I do that, what I need to do is I need to go into the enemy prefab. So I think I can do open select. Yeah, we can select the prefab here. Then we can add a health component to it. And there's other ways I could have done this. I could have done it by having the player and the enemy inherit from health. But if I hit you, you should die. I'm shooting over you? Is that what I'm doing? Am I actually shooting over you? I think I am. No, that should be colliding. Did I forget something? You're not a trigger. Let me say debug.log. Let's say hit. Let's say other.gameObject.name. Not health return, otherwise health.take damage. Yeah, that should work. Uncertain why. Okay. Yeah, it did hit. Oh, okay. Oh, because we're hitting the actual, right, okay. The way that I did this is not great. Yeah, I put the... Okay, we can just get the component and the parent. So what's happening is, where's the health bar component? It's not a child. It's not in a child or parent. Yeah, I think you're right. It's in a parent. There was a reason that I did it this way. It's probably not a great reason, but there was a reason. But yeah, I probably shouldn't have done it this way. So one way that we can fix this, but yeah, you're right that the health bar is in the parent, yeah, or in the child. So how do I want to do this actually? Because I need two colliders. I need one so that it'll collide with the world and one so that it can register hits. Or actually, wait, no, wait a minute. No, because I need one so that it'll collide with the walls, but another one, yeah, what I'll do is I'll just get rid of the non-trigger version. Actually, yeah, because I can make the enemies not collide with themselves. What am I doing? I don't know why I'm doing it this way. Sure, let's just remove both of these for the moment. And what I'm going to do is I'm just going to put the box collider here. It should just work. Of course, it needs to be scaled correctly. 0.4.4 and at 0.2. And I think the enemies rotate the base object. I think that's what they do. And this doesn't need to be a trigger, right? I don't know what I'm doing. Yeah, they rotate. Well, actually, that doesn't necessarily mean they rotate the base object. Yeah, they do. Okay. Okay, so yeah, this should work. Yeah, there we go. So what happens is it gets hit, and then it triggers the take damage. Since the enemy only has 1 health, it triggers the die, and then it destroys itself. Cool. Okay, so if we have multiple copies of these enemies, they should all die. Yeah, okay. But now the projectiles are not getting destroyed by the walls. So you can see that they're existing out here in space, and we need to get rid of that. So an easy way to do that, actually, I modified this version of the enemy, didn't I? Yes, I did. Alright, well, let's apply that, and then we can delete that. That's fine. We can delete that, that's fine. How do I get out of this? Is it like that? Yeah, it is, okay. And then I think we can apply the changes here. And then if I open this, I think it has the right changes. Yeah, so it'll have the model, and then it'll have... We really don't need this, but I'm going to keep it just in case. It's not causing too many issues quite yet. So yeah, we need to make sure that the projectiles are destroyed when they hit the walls. So the way we're going to do that is we're going to create... We either create a layer or a tag. We'll create a tag. So yeah, if we want to create our own little tag here, what we can do is we can say add tag, and then call this wall. Interesting. Okay. And so we'll go into the wall itself. We will just change this. Do you have the hitbox? Yeah, you have the hitbox. I don't know why you have the hitbox. Tell you what, you don't have the hitbox anymore. So say box collider here. And yeah, I just moved the box collider from here up to here because it just makes more sense. And so what we'll do is we'll add the tag of wall. And so what that will do for us is all of these will be considered walls. So in the projectile component itself, we can say that if, let me think about this. Is there an elegant way to do this? I don't think so. So what we can say is we can say if the other dot, I think it's game object dot compare tag is wall. So compare tag is basically the same thing as doing tag is equal to. So you could do other.game.tag equal to wall. So basically we just want to check if the other thing is a wall. And it will even, I think, recommend that we don't do this. I think it'll recommend we do that, yeah. And if the other thing is a wall, then we just want to destroy ourselves, and then we just return, because we don't want to do anything else. It doesn't matter if the other thing has health or not. We don't care. So in this case, because these have the tag of wall, and because the collider's in the right place now, it should destroy, projectiles should destroy themselves when they hit the wall, which they do, I think. I think that's what I saw, yeah, okay. So yeah, you can see they're destroying themselves when they hit the wall, they're not damaging us, and they're also not destroying each other when they hit each other. Okay. So that's kind of what we wanted to do. And then, I think the other thing too is, let's say we call this 5 health. We should be able to hit this enemy 5 times before it kills itself, or before it dies. So 1, 2, 3, 4, and 5. Have you ever tried, so this is from Gamedev, have you ever tried making an online multiplayer game? Yes, I have. I did it ages ago when Photon was still, well, I did it before the, when Unity Master Server was a thing. When they had their own like Master Server service, I did it on that. And then I switched to Photon, and yeah, it's a lot of fun. It's also extremely hard. But yeah, I have done it before. Are you trying to make one yourself? So yeah, we have this working. So we can give enemies different health, so that's good to know. So I'm trying to think of the next thing that we need to do here. Oh yeah, the projectile modifications. So yeah, let's try that, the projectile modifications. So in the game that we were emulating, if I can find it, where was it? It was in the Scorespace Jam 12. Let me see if I can find actual games. No, I don't want to be here. Game Jam Beta Grand Magus? I think that's right. No? Alright, well, definitely interested in making one with my friend once I get a few single-player projects. Okay, yeah, they're a lot of fun to make. There's a lot of things to think about. I'm trying to think of good advice for that. How long have you been a game dev for? I've technically it's been over 10 years, because the first thing that I did was in high school. I would do games on my TI-83 calculator, and that was a lot of fun. But yeah, so this is the game that we've been asked to emulate. And what it is, you have these 3 little things that rotate around, and they determine how powerful and how quick your bullets are. And so we need to do that sort of thing. So yeah, the first thing I want to do is I want to get the rotating part working, which is actually super easy to do. Yeah, it was actually funny because in high school I would have that calculator out, like programming with one hand while I was walking between classes, and I got stopped multiple times for because teachers thought that it was a cell phone, because it looked like I was texting, and then I would show them, no, this thing is just a calculator for math. It was great though, because I could program all the way through math class, and the teacher never said anything because it looked like I was just doing work, and so it was great. But yeah, to make things in Unity rotate around other things, it's actually super easy to do. Playing checkers while you're playing chess. Yeah, basically. It was great. I loved high school. But yeah, what we're going to do is to make things rotate around each other in Unity is actually not hard to do at all. Because Unity, whenever you rotate something, it'll rotate, like whenever you have a game object that's a child of another game object, so if I make this really tiny really quick, and I move it, say, out here, since this cube is a child of this game object, if I start rotating this game object, it'll rotate the cube itself. The caveat with this is that you need to make sure the thing that you're rotating has a scale of, I think it has to be an even scale, like a uniform scale. Yeah, of like 1, 1, 1 or 2, 2, 2 or something like that. It's easiest if it's 1, 1, 1 because that just makes more sense. But if it's an uneven scale, you get some weird effects from Unity. Let's see if I can actually make it happen. So let's say it's 0.2. Let's say this is 0.3 so we can actually see it. I don't know what this will actually do, but I think if we start rotating this, maybe it's not happening. I don't know how you actually make it happen, but there are some weird things you could find with this. Let's see. No, it's not doing it now, but sometimes it does, where it like bends the vertices. It looks really weird. But anyway, yeah, if you're going to be rotating things, the best policy is to just have it be at 1, 1, 1, or the scale of 1, 1, 1. It just makes the most sense. But anyway, so what we're going to basically do is we're going to create 3 of these little cubes, and then we are going to rotate them, or we're going to space them along the outside of this and then rotate them. So I'm trying to think of what a good scale might be. Let's see, 0.1? No, that's too tiny, definitely. But 0.2 looked too big. Is that true? Yeah, 0.15 probably. Okay, so we can get rid of the collider because we don't need that. And then we can create this. What I want this to be is I want this to be at 120. So sort of an easy way to do that is to just duplicate this, rotate it to 120. Whoops, that's the wrong axis, y-axis. 120. Now I can just basically take this and move it over here, because now it has the same offset. And we can do the same thing again. I think if I rotate this 120, now that one down there is at the correct place. So I can just grab it and move it into this one. And now we have 3 of them, and so if I rotate this object, we'll have them rotating, 20 degrees apart. So yeah, that's what we want to do, and so we want to make this rotate, and so that's really easy to do. All we need to do is we need to just change the rotation of that object every frame. So I'll call this like a rotate component. And this, of course, because Unity is being cooperative, will not actually open it up. Oops, we need Unity Engine. So in private void rotate, all we're going to do is we're just going to modify the rotation every frame. And so we say transform.rotation, and with quaternions, you can actually, if you want to add rotation to something, you can say times equal. That will rotate this rotation by whatever rotation we put on the right. So if I want to rotate by, let's say, I think it's 90 degrees, let's say like 90 degrees per second or something. What we do is we say quaternion, say quaternion dot Euler, and so this will create a quaternion from Euler angles. The difference is that a quaternion is a crazy 4-dimensional object. It's basically, the way that a quaternion works is that you're taking a 4-dimensional sphere and you're projecting it into the 3-dimensional space, which causes it to just be insanely complicated to think about. So if you use like Euler angles, it just makes a lot more sense. But if you know how quaternions work, they're really, really fast. But yeah. So what we're just going to say is we're going to create a quaternion with 90 degrees on the y-axis because we want to rotate along the y-axis. And what we will do is we will say 90 degrees, I think we say times time.delta time. So this will be 90 degrees per second. Yes. And then we just rotate the transform by that. And so what I'll do is I'll have a public, well actually no, have a protected float speed. What this will do is this will just let us increase or decrease the speed. And of course we could just put the speed, well actually, we might as well just put the speed here. Makes more sense. We'll just put it at 90, yeah. That way we can change the speed of these things individually. Or, I plan to reuse the rotation component on the cubes themselves. But anyway, This will be the rotator, and we'll just put the rotate component on it. Oh yeah, I didn't put the serialized field. So to make Unity deal with protected fields, you have to say serialized field. And then the Unity inspector will just magically make it work. I sort of know why, but I think it's lame. But anyway, as you can see, they rotate. Oh, they rotate relative to us. We don't want that. So this is messing with, I think, their local rotation? Interesting. Can I say no? Okay. I thought that rotation and local rotation were different. Is that true? This should... I would think that this would have the same effect, but maybe I'm wrong. Yeah, that has the same effect. I don't know why... Oh, so, okay. There is a way we can do this. So what we can say, rather than rotating the transform's rotation, we can just say that it's equal to the delta time, I think times just the speed times time dot time. And what this will do is, because time dot time is constantly ticking up, and the difference between the time last frame and this frame is equal to delta time, this will just set the absolute rotation equal to that. And what will happen is, because this is the absolute rotation, it will not have the issue that we have here. And also, typical programming before this rotation is very simple. After, why is it doing that? Yep, exactly. It's like, oh yeah, I forgot to account for the fact that the parent object is also rotating. But I think I fixed it now. Yeah, okay, so now, it's very simple to make something rotate, and Unity was doing exactly what I wanted it to do. Sorry, Unity was doing exactly what I told it to do, which was not what I wanted it to do. But yeah, now it's working. And so, of course, again, the reason that it's working is because we're setting the transform dot rotation directly rather than rotating it itself. And so the time dot time times speed, basically we're just accelerating the time times the speed. The quaternion is nice in that if you assign, the Euler angles are nice in that they loop automatically. So if we say that something, since there's 360 degrees in a circle, if we say that, you know, we want something to be at degree 361, it automatically knows that that's actually 1 degree, so it loops automatically. So that's perfect. And so now we can basically go to the cubes themselves, and we can add the rotate component, and that way the cubes themselves will also rotate. And so now, yeah, as you can see, they're rotating on their own, which is perfect, which is exactly what we want. Okay, so now, in this game, let me mute this. Whoops, no, I don't want to pin that. I want to mute it. Anyway, so the way that this game works is by play. So we have the three little rotating things. So if I press if I press C, what happens is they turn red, and what that means is that my projectiles are actually more powerful. So the little red spheres make it more powerful. So if I press C, for instance, X, I'll get the blue ones. Those are less powerful, but they have a much lower reload time. And if I press Z, we get green ones, and the projectiles become slower but larger. So that's sort of what this does. We're trying to create a system similar to that. So there's a couple ways we could do that. One of them is that we could modify the material on the cube, and I think we're probably going to do that. Another one is we could just have a different cube. But no, I think what we're going to do is we're going to modify the material. So I think we need blue, blue, red, and green. So we have red, we have blue, we just need green. So let's duplicate this, make it green. And so we're going to have green be like that. fine. And yeah, they can start off as green. Okay. So now comes the fun part, actually making this work. So I think what we're going to do... Ooh, I do have a question though. Okay, let me answer my own question first. So my question is, if I create a queue, is Unity smart enough to work with that? So let's check this out. Or is the Unity inspector smart enough to deal with that? My guess is no. So a queue is in system.collections.generic. So if I create a public queue game object, and we'll say cubes. Let's see what this actually does. Is it smart enough? The answer is no. Okay, that's unfortunate. So we will have to use a list instead. So what we want to do is we want to figure out, so given these 3 cubes, right, we want to know if the player presses X, we want to say, hey, okay, go to the next cube, whatever it might be, and turn that one, you know, blue. So we have to keep track of, so if we turn this one blue and then we press X again, we don't want to turn this one blue, we want to turn this one blue. So we basically have to store them in some kind of order. And so we're going to use a list. And so a list is kind of like an array, it's just strictly better. W can check me on that and tell me if that's actually true. I'm 99% sure that a list is just a strict upgrade from an array, but I might be wrong. I know there's some speed issues, or there might be. I know there's some speed differences, but normally it doesn't matter. So now that I've turned this into a list, I believe the Unity inspector can deal with it. So if I select the player, did I put this somewhere else? Also, why am I... No, this isn't the player controller. Am I crazy? Isn't Unity able to do this? Or does it actually have to be public? Okay, what's going on? Why is that not working? Oh, because I'm putting this in projectile. Jeez, I'm dumb. Because I read thing there, I was like, oh, this is probably player, right? No, it's not. Clicked on the wrong thing. That's why it's not working. Yeah, usually you want, you just want a list, I think. An array has a fixed size, so I can't grow or shrink. Okay, yeah. I was pretty sure that that one was a strict upgrade from the other, but I just wanted to double check, because I might be crazy. Okay, so actually we want collections generic here, we don't want that in here. Right, alright. Pro tip, whenever you're writing code, make sure you're doing the thing that you think you're doing. So okay, let me just make sure, let me set this to cubes. Okay, so yeah, this should appear right here because this is the player controller. Okay, that's what I was looking for, is the cubes there. Alright, so now we can make this serialized. Right. Okay, and that changes nothing. Good. And so now let me just double check with the queue. I don't think Unity is good enough to do it, but let's just check. I might be pleasantly surprised. Nope, Unity can't do it. Sad. Okay. We're gonna have to just create our own queue. Alright, and so we don't want this to be game objects, we actually want this to be the mesh renderer, I believe. Because, where is it? The mesh renderer has the, you can't see it here, no, you can see it here, yeah. So if we have this materials list, so I believe if we add blue here, yeah, it turns blue. So that's what we want, is we want to mess with the mesh renderer, we don't really care about the game object. So instead of a list of game objects, I'm just going to call this a list of mesh renderers. And so now, I guess we're going to create, or we're going to go in here. We're going to say if input, we're going to say get key down, because so if we press the Z key, so keycode.z, what we want to do is we want to modify one of the crystal things, or one of the cubes. So we're going to say cubes at 0, which is going to be the first one. We're going to say material, and we're going to set that equal to some material. So I do want to have a couple other material colors here. We're going to have a couple materials that represent each of the different colors. So we'll have protected material, we'll say red, and then we'll have a couple others. So Control D, blue and green. And we can serialize those. There is a way to put headers in the inspector, and I should do that. I don't remember what it is though. Is it like just header? Yeah, it's header, and then I think it's like name equals something, or no? Is it just header cube or cube colors, or just colors, I guess? So what this will do is in the inspector, what we'll get is we'll get a section called colors, I think. Oh, that's not how that works? Oh, right. We have empty expression. Hold on. So in the player component, or player controller, where is it? Yeah, we get this thing that says colors, and so it just has the colors below there. Let's assign those really quick. We'll say green. That's not green. We can do red. Blue. Let's use the darker blue, actually. And then we'll use green. Okay. So with this, what we can do is we can say cubes of 0.color or .material is equal to green. So that's going to be for Z, and then for the other two, we're going to say for X and for C, I believe X is blue and C is red. And so this should only work on the first cube for now. We can make it swap between them later. So what we need to do is now if we press X, C, or C, we'll get an issue for null, for array, for argument out of range exception. So if you get an argument out of range exception, what that will do, or where that will be, I should say, is it will be in the list itself, or it'll be here because Unity is dumb. But what it's telling us is that this cubes at 0 doesn't exist, because cubes has a size of 0, and we're trying to get the first element, which, so 1 being greater than 0 is the issue. So what we need to do is we need to actually assign the cubes to the list. So you can see we have this cubes list here, it has nothing in it. An easy way to sort of do this is that you can click this lock icon, which will lock the inspector. So now if I click on other stuff, it selects it, but it doesn't actually change my inspector. You can use Shift to grab everything, and then you can drop it on top of this list, and it'll put things in this list in order as well. So in the order that you selected them, which is awesome. So now what this will work. So now if I press C, nothing happens because this is already green. If I press X, you see it turns blue. If I press C, you see it turns red. And so yeah, now what we want to do is if I press C multiple times, I want it to, oh, that's interesting. It does sometimes twitch a little bit. I think it has to do with either the rendering or the physics or something. Something weird. But that doesn't really matter. So yeah, what we want to do is we want to say, okay, since we've changed the material, or since we've changed the first cube, what we want to do is we want to take the first cube and we want to put it at the end of the list. So I believe you can add, or yeah, you can just add something to the end of a list. So what we'll say is we'll say the game object, or no, we'll say mesh renderer, because that's what it is. Say mesh renderer say cube, I guess, will be cubes of 0. Can't type that. Will be cubes of 0. So we want to save which cube we have. Then we want to say cubes of 0 dot remove. So we want to remove this cube. Or sorry, let's say cubes dot remove at 0. Or I think it's remove at. Yeah, remove at 0. So this will remove the first cube from the list, but we still have it saved up here. And so then we say cubes dot add. And so this will add it back to the end of the list. So if we had, or not add 0, but add cube. So yeah, basically what we want to do is, so if we have, let's say we have green, or say we have red, green, and green in our list, what we'll end up doing is we'll just save it for the first one and then remove at 0. So we'll change it to, the list will be green, and then at the end here it will be green, green, and red. So the next cube we modify will be the first green one. So that's what we want to do. And what I'm going to do is I'm actually going to grab this because this code is going to be the same here and here. So we'll just create a protected method. And we'll say cycle cubes. And so we'll just call cycle cubes. Whoa, I don't know what I just did there. But that's not what I wanted to do. Didn't want to do any of that. That causes issues. That causes issues. Just want to do cycle cubes there. And then we'll copy that, paste it here, and then we can replace this since we just moved it into a method. So now whenever we hit Z, we turn the first cube green and then we cycle the cubes. So what that should result in is whenever I press, let's say X, turn this cube blue, now this one should turn blue. Yeah. So as you can see, it's cycling through them. So if I said, C, 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 we get 3 red ones, can do multiple colors and it'll change the one that we expect. So it'll just cycle through them. Yeah. As you can see, that kind of works now. So now we actually can, cycle through the colors and stuff like that. So what we need to do is now we need to store basically a similar thing for the size and the speed and then the reload. So right now we don't have any reload or anything. So we need to probably, let's change the size first. I'm trying to think of a good way to do this. There's complicated ways to do this, but I think I'm just going to do it the easy way and it's going to bother me. Okay, what we'll do, I'll do it in the not terrible way. The not complicated way, but the not terrible way. So what we have is we have 3 things, right? We can either increase the reload, we can either change the reload, we can change the damage, or we can change the size. So when you have 3 sort of things or when you have a set of values, like just a strict set of values, what you usually want is an enumeration. So what we need to do is we need to store basically the size, the damage, and whatnot. What we can do, one option is we could say, like we have a list of cubes, we could have a list of modifiers to the projectile. And so this has got to be a list of some kind. So we could have a list of integers. And so then we could say, if there's a 0, then we change the damage. If there's a 1, then we change the reload time. Or if there's a 2, then we change the size. But, then what happens if you have a 3, right? So what we can do is instead we can use what's called an enum. So we can have what is it? It's a projectile modifier. Modifier? Yeah, sure. And so instead of a class, this will be an enum. And so basically an enum is just a set of, it's basically a list, like a strict set of values. Like whenever you enumerate something, that means to list all the possibilities. So in this case, we have three possibilities. We have damage, reload, and size. So we'll say damage, we'll say reload, and size. And this is looking weird to me, but I think it's working. But yeah, now it's not possible for us to have, this extra thing. So instead of having an int, we'll have a list of projectile modifiers. And so yeah, we'll just store the projectile modifiers into it. So for now, since everything starts as green, what we're going to do is, actually I think this can be serialized. I think that's correct. I think you can, actually let me double check. I actually don't know. I'm curious. Ah, yeah, you can, okay. So never mind, we don't have to do anything crazy. So now we have projectile modifiers. Green was not damage, it was size. So yeah, we can just select, so as you can see in the inspector here, we actually can't select anything other than these three, so we don't have to deal with any other case. So what we'll do is we'll do basically the same thing that we do with the cubes, right, is that we'll just cycle the modifier. Actually, no, we don't even need to do that. Okay, so now that we have this list of modifiers, we need to read from it, right? We need to know whenever we fire a projectile, what kind of modifiers does it have? So I believe in handle shooting, we're going to have to do that. We're somehow going to have to change the size of this projectile. And so I guess in initialize, that'll have to work. So yeah, in initialize, what we'll do is we'll pass in modifiers. And so that's going to give us an error, because initialize doesn't take that. So we can control click, go into it. We can say list, that we want to take in a list of projectile modifiers. Then we'll call this modifiers. What it doesn't like is it doesn't like that we have an imported list, so we need to say using system.collections.generic. I would say just memorize system.collections.generic because you'll need it a lot. But yeah, with the modifiers here, what we can do is we can have the projectile itself figure out what its speed, velocity, or speed and size and reload are. So what we'll say, actually since we're giving it its speed, we just need to have it determine its size. And so what that means is that we just say that we want to go through modifiers and say for each projectile modifier in modifiers. So basically we want to go through each one of these, and then if we find one that has the value of size, so if this modifier is equal to size, then what we want to do is we want to increase our own projectile size. So we'll say if modifier is equal to projectile modifier dot size, then what we want to say is transform dot scale, and we want to, or say, I think it's local scale, right? Yeah, local scale. Then we will say, we're going to say that it's equal to itself, transform dot local scale. And we can say times vector3.1, so that's vector3.1 is just 111 on all axes. And then what we can do is, if we want to say it's times 1.25, I believe this will work. 1.25 f. Why is it not like that? Equal to transform.local scale. Cannot be applied to vector 3. Oh, right. Right. Can it not? Is it just... no. Right. But can you not apply... Right, what am I thinking here? No, really, what am I thinking? I want it to be equal to itself. I guess we don't need vector 3.1. I think we only need to just multiply it by 1.25. Okay, yeah, that'll be fair. So it'll scale times 1.25f. Okay, yeah, you're right. I don't know why I'm thinking... I think I was thinking plus equals. Do we want to do plus equals? Yeah, actually plus equals is probably better. Well, no. No, we'll just increase it by 25%. So, well, actually, increase it by 10%. You can add two vectors. Yeah, okay. You can't multiply two vectors. Well, oh, you can't multiply... Oh, yeah, because you couldn't... Okay, so there's no... Right, because unity vectors... this is where vector math gets fun. Right, so if I'm trying to remember, because unity vectors are 1 by 3. So you can't do a 1 by 3 times a 1 by 3. But if I had some way of representing a 3 by 1 vector, then I could do that and I'd get a 3 by... No, I'd get a 1 by 1. Is that how that works? Is that vector math? You can multiply them if that number is the same and then it's equal to that number? I think that's how that works. And so now if I had a 3 by 1 and a 1 by 3, then I'd multiply it and I would get a 3 by 3. I think that's how vector math works. It's been a long time since I've taken vector math, but yeah, I think that's how it works. Okay. I mean, does what I say, or what I just said, does that sound approximately right? Because I think that's approximately right. But since in Unity you can only represent 1 by 3 vectors, I think you can never multiply them. But yeah, this should basically, so what this will do is this will increase the size of the projectile by 10% for each projectile modifier. And it's sort of, it's not exactly 10%, it'll be a little bit more, just because we're reapplying it each time. So, you know, the second time this hits, it'll be 1.1 times 1.1, which isn't exactly 1.2, it's a little bit more. But anyway, it doesn't really matter. Basically what this will do is, for each modifier we have, we increase the size of the projectile. And I don't think we're doing that yet. The reason that we're not doing it is because we haven't, when the player presses these buttons, we're not actually adding anything to the modifiers list. So actually, instead of cycle cubes, we'll put this in cycle cubes. So what we want to do is we want to say modifiers of 0 is equal to, oh no, you can't actually, oh no, you actually can do that. So it's equal to, I think for Z it was for green, so it's equal to projectile modifier dot size. And then in the case of blue, it's going to be equal to reload, which we don't have implemented yet. And in the case of red, it's going to be equal to damage, which we do have implemented, but we just don't have the player storing that quite yet. So the only one that's going to work is the size one, but we can use that to ensure that our logic is working. And so in cycle cubes, we want to do exactly the same thing that we're doing for cubes, we just want to do that for modifiers. So we'll say projectile modifier, modifier is equal to modifiers of 0. And then we want to say modifiers dot remove at 0 and modifiers dot add modifier. There might be a more efficient way to do this. I don't think we actually need, there's probably a more efficient way to do this, but I can't think of it right now. But yeah, I hope this sort of makes some level of sense. But yeah, if this worked, what will happen is the projectiles will be fairly large, and they should change size. So they're that size now. You could use int current index maybe, and int current index maybe. So I can't tell. Yeah, as you can see, the projectiles are getting smaller. So in this case, they're at 0.3. That's their lowest. But if we have 3 green crystals, they are at still 0.3. Oh, that's the sphere. Then have a loop around for the size. Could use an int current index. Yeah, I think you're right. Because I was doing that. I think I do that for the list view thing, is that it does like modulus or something. And you can like, if you add the modifier plus the size, yeah. If you add modifier, you're like the change in the index plus the size of the, plus the count of the list, then you do a modulus on it, it ends up like looping automatically, which is great. But yeah, as you can see, this is 1.331. And so if I change to some other color that's not green, and we look at the bullets, they're at 1.0. So they are changing size depending on which, depending on how many of the modifiers we have. So actually, I'm going to increase this to 1.25. I think I was kind of spot on with that. But now the change should really be evident. Let's go 3 green or 3 blue. So you see that. Now let's go 1 green. So you can see they're a little bit bigger. Then we do green again, a little bit bigger. Green a little bit bigger. Yeah. So as you can see, as you can see, that's how that works. So we can change the damage in a similar way. So since we are passing in, I think we pass in the damage to the component. We do not. That's interesting. Okay, so we have take damage here. So what we want to do is we want to move this number into a variable. So we'll say protected float, or is it float? No, it's int. Damage. And we'll store that there, and then we'll have it be in here. So the damage will be equal to whatever damage is. And then in modifiers, what we can say is we can say if modifier is equal to projectile modifier.damage, then we can say damage plus equal to, I don't know, 3. And then the default damage will just be 1. Say damage is equal to 1. So we'll say that, you know, if there's one of them, we'll have 1, or let's say 2 damage. So for 1, there is 1 damage. You know, for 0 red cubes, there is 1 damage. For 2, there's 3. For 3, there is, or for 2, there is 5. For 3, there is 7. Whoops, I don't know what I just did there. So if you have multiple if statements in a row like this, you can have what's called a switch statement. So you can say switch, and you say, okay, what do you want to switch on? So we want to switch on the modifier, because that's what's here and that's what's here. And then you can have multiple cases. So you can say the case is equal to projectile modifier dot damage, or say dot size. So what this says is when modifier is equal to projectile modifier dot size, we want to do this, and we want to break. Otherwise, when it's equal to dot damage, we want to do something else. And at the end of a case statement, I think you normally need a break statement. Yeah, we can get rid of this. And this just conveys the point a little bit more clearly that there's going to be a fixed number of things that we're going to do with this. And so one of them is going to be when the modifier is equal to the size, we change the size. When it's equal to the damage, we change the damage. I don't like switch statements, but the other ways of doing this are more complicated, so we're just going to do this for now. I'm trying to keep this as like minimally complicated as possible. So this will change the damage. We can't see that because this enemy has a single point of health, but what we'll do is we will duplicate this, and we will say that this enemy has, we'll say that it has 7 health, and that way we can see this a little bit better. So the first enemy, it will die to a single hit, so you can see that, but this one will not, because it has more than 1 health, and You can actually see that its health is 6, because, well, now it's 5, because our projectiles normally do 1 damage. But if we hit, I think it's C? Yeah, if we hit C, our projectiles now do 3 damage, so its health is going to go down to 2 whenever it gets hit. And so as you can see, it goes down to 2, then we hit it again and it dies. So we can actually give ourselves 3 red crystals, and we should kill it in 1 hit, because each red crystal does 2 damage, and we do a base of 1, so this is 6 plus 1, which is 7. So if we look at this enemy, you'll see its health go right to 0, and so yeah, that's how we know that this is working. So the final thing we need to do is a reload. And so the reload's actually not super hard to do. I will go for another hour, and then we'll probably call it from there. Okay. So does this make sense, Omar? I'm trying to explain it, trying to keep it as minimally complicated as possible. But like, does everything make sense and everything? Because I hope it does. But yeah, because like that's one thing that I've been trying to work on, is trying to explain things so that other people know what I'm talking about. Because, you know, if I'm talking I'm talking like crazy and just saying a bunch of stuff, it doesn't help anybody if nobody understands it. Okay, but if you have questions, feel free to stop me and ask, because, you know, yeah, feel free to ask, because, you know, the Twitch chat's kind of right there, and yeah. But yeah, I hope it makes sense. But yeah, if I gloss over anything, feel free to stop me, because, yeah. So the next thing that we want to fix is the actual, like, shooting. Well, actually, before that, we want to move this into its own method, just because we have everything else moved into its own method. So we can say protected void handle cubes, I guess. And then we can grab this, move it into its own method, and then we can put it over here. Okay, but the word kinda is good because I'm a beginner, and from a normal calculator, we are here making a game. Yeah, that's fair. But yeah, if I say something, or if I use some kind of word that doesn't make sense, just feel free to like stop and ask me, because, you know, I might use something that, you know, makes sense to me but doesn't make sense otherwise. But yeah, so I'm trying to not do complicated stuff. Like my natural urge is to do things in very complicated ways, but I'm trying to do it like, you know, 1 step at a time. I also have a natural urge to like solve 6 problems at the same time, just because my brain can think like 6 moves ahead. I'm trying to do it 1 move at a time. But yeah, it's also the case that I've done like projectiles and stuff many times, and so yeah. But yeah, we need to add a shooting, or a cooldown. So basically, if the player tries to shoot, so okay, let me just show it. Okay, pretty good graphic designer. I'll make an overlay for your Twitch. Oh, okay, that would be really good, because yeah, my huge weakness is design, or art, like art. You say so. Sorry, not sure what that was in response to, but yeah, yeah, that would be good, because my biggest weakness, like, I can make things work, but I cannot for the life of me make them look good. Like, I don't know if you saw the pre-stream kind of like spaceship, but that's the pinnacle of my artwork over 5 years. So it's the very best that I can do. Yeah, this thing will shoot. Basically the player can shoot as quickly as I can click, and we don't necessarily want that. We want to make it so that the player's shooting, like max shooting rate, is dependent on how many crystals they have, or how many cubes they have, or basically what type of cubes they have. So one thing the original didn't do was it wasn't click to hold, or it wasn't hold to shoot, which I was not a huge fan of, so we're going to make it do that now. So instead of checking whether the mouse button is down, we want to actually just check whether, whenever we use get mouse button down, what happens is it returns true only whenever we click, like only one frame. Like if I click, we get exactly one, we get exactly one instance of that. Whereas if I say get mouse button, this will check if it's down. So if I do this, I don't know if this will crash Unity, but you'll see the difference like right away. So if I hold, yeah, that's what happens, because 60 times per second it's spawning a new projectile. Clearly we don't want that, but you can see the difference. The enemy is very slow also. Yeah, you're right. We can actually change the enemy's movement speed. I don't know how. Let's say maybe 4. How fast are you now? Oh, you're quite a threat. Yep, you're quite a threat. Okay. But yeah, as you can see, even one click it does that. Yeah, it's like kind of a snake almost. It does produce kind of a cool effect, but it's a little unfair from our perspective. But yeah, I want to change the, you can see the difference. Is that, even if I click once, you see we get multiple projectiles. It's because it's being held down for multiple frames. So what we want to do is we want to create, we basically want to create a thing. We want to store the next time that the player is allowed to fire. So we want to say if the mouse button is down and, well actually, we can do this better. We can say, yeah, that's boss mode. Yeah, exactly. What we're going to do is we're going to store a float. We're going to say protected float next fire time. So the reason for this is that time in Unity is handled as a float. So what we're going to say is we're going to say in handle shooting, if the time dot time is less than the next fire time. So if so this is the next time that we're allowed to fire. So let's say we have like a 1 second cooldown, right? Cooldown of 1 second. If the current time is, if we fire and the time is equal to 5, the next fire time is going to be equal to the current time, which is 5, plus the cooldown, which is 1, so it's going to be 6. So that's what next fire time is going to be. So in our case, if the current time is less than the next fire time, for shooting, we don't care what happens, we just want to return. We just want to ignore whatever the player is doing, because really, who cares? And then if the time is after the next fire time, which is what's going to be right here, if the player tries to shoot, the next fire time is going to be equal to time.time, which is the current time. And we'll say plus 1 for now. And we'll make it a variable later. So this basically says that we can fire 1 time per second, if I did that right. So now, if I click and hold, you see we get 1 bullet per second. It's really slow. Okay. So now, what we need to do is we need to store this in a variable. So we'll say that this is equal to cooldown. And that means that we need a cooldown variable. So say protected float cooldown. And we'll say that that's equal to 1. No, we'll say that's equal to half a second. So we should fire a little bit faster now, just to prove that this is kind of working. And then we can change it a little bit later. So now you see we fire slightly faster. We fire 2 times a second, which is pretty good. But now we can set it equal to, I guess the base is going to be maybe 3 times a second. And then what we'll do is in, I believe, cycle cubes, what we need to do is, yeah, probably in cycle cubes, because if we're cycling the cubes, well, no, actually, yeah, I think what we'll do is, yeah, in cycle cubes, what we're going to do is we're going to reset the cooldown here, because cycle cubes is called every single time the cubes are changed. So what we could do is in here we could say, if blue, we could say cooldown is equal to, we could say for cooldown it's equal to you know, or we could say we could lower the cooldown by 0.1. We could say that, and then the problem is, so this means that every time we add a blue cube, we lower the cooldown, right? So if we lower the cooldown, we fire faster. But then conversely, over here, we'd have to remember that what we want to do is that we want to add back, actually no, we'd need to check if, we'd need to say if, you know, cubes of 0 is, you know, no, it's not cubes. We'd say if modifiers of 0 is equal to projectile modifier dot reload, then we'd have to say, you know, cooldown plus equal to 0.1 again. So what I'm getting at is that we could modify the cooldown here, but then we'd also have to remember that in here and in here, we need to put it back. Or what we could do, and what I'm going to do, is we can notice that every time we modify what cubes we have, we call cycle cubes. So in that case, what we can do is we can just recompute the cooldown in here. So we can say, we can count the number of blue cubes, right? We can say that the int blue cubes is going to be equal to 0. And we can say for each modifier, I think it's projectile modifier, in modifiers, we can say if the modifier is projectile modifier dot reload, and we say blue cubes plus equal to 1, and I don't know why that went all weird, but it did. And so now, why does it not like it? Oh, because we have modifier up here. Okay. That is fair. So I will just call this projectile modifier. Basically what it didn't like is that I was using, I have modifier up here, so it didn't like that I was using it down there. Actually, a bad trick you can do. Show you a bad trick you can do. Don't do this, but I'm going to do it because one thing you may not know is that the curly brackets, they create a scope. So scope basically means that, so for instance, I can use cube right now out here because it's valid, but if I were to put curly brackets around this, this is still valid code, but I can't use cube out here anymore because cube is only valid inside these curly brackets. So I can actually do the same thing with modifier, is what I can do. I can put brackets around it, and now it executes like normal, but this modifier can now be used again. It's a very bad practice. Don't do it, but I'm gonna do it because it's funny. Just showing you something you can do with the language. And if you ever see someone do this, slap them on the wrist because you really shouldn't. But yeah, we're gonna do that because it's not harmful in this case. And so what we're gonna say is that the cooldown is going to be equal to, let's say, I don't know, I guess the base can be it's like, what's the base going to be? Let's say 0.5 maybe? No, because 0.5 is really slow. Maybe 0.25? Now I'll say it's 0.4. I know that we set it to 0.3, but we'll have to fix it later. We'll say it's 0.4 plus the number of blue cubes. Or sorry, not plus, but minus. Blue cubes times, I don't know, 0.7? Or no, 0.07, or something like that. So basically what this does is this will recompute the cooldown every single time we cycle the cubes. And the advantage of that is that we don't have to worry about messing with it. Drew Manfu. Never done that before. I always just make a new variable so no slaps on my wrist. Yeah, I like showing off just funny things that people don't realize. Like, there's a lot of people who don't realize that you can just create a new scope like that in, I think this is valid in C as well. I know that it's valid in Java as well. You can also do this. I've never seen, I guess it's good that nobody knows that you can do this because it's generally considered a really bad thing to do. But yeah, a lot of people don't realize you can do it. And so I think it's funny, or at work I thought that it was funny to submit code with this because it would really confuse people. Like even my boss who knew the language was like, what does that mean? And I'm like, it doesn't mean anything. It just does that. Yeah, but I think it's kind of funny. I like to show off features that people don't really realize are in the language. But okay. So, yeah, it's really funny. It's really funny to just watch people's minds get bent with it. Other things too. It's also really funny because a lot of people don't realize that in Java, the integers between... I don't think I knew you could do that in C#. So there's something you can do in Java that a lot of people don't know. In Java, they have a difference between int and integer. So in Java, this is a primitive. You can't assign null to this. An integer you can. So integer like represents the object version of int. But in Java, the integer objects between, I think it's minus 127 and positive 128, or no, it's minus 128 to positive 127. These are actually like object literals. So there's like a giant array in Java that is 255 integer objects in the JVM. And so if you say, integer 128, this is like a static value, or sorry, integer 127, this is like a static value. So integer, so like if you were to have integer a is equal to 127 and integer b is equal to 127, then normally a is equal to b. But if you were to say like, 300 and 300, then a is not equal to b because these aren't cached, they're actually two different objects. But the funny thing is that you can actually go in with reflection and you can mess with that array. So if you can actually say that, so if you said something like integer a is equal to 3, you can actually go in and mess with 3 and make it 4. So what you can do is you can do this, and then a plus b will be equal to 8, which is really stupid. But yeah, you can go in and do that. It's really, really funny to do. And you only have to do it once to completely screw up all the math. It's so terrible. But yeah, go ahead, go try that. It's really fun. But I don't know if you can do it in C#. I don't think you can. I think they've fixed it so that you can't do stupid things like that. But it's really funny. But yeah. So this is just back to what we were doing. The way of doing this here, where we compute the number of blue cubes, is just slightly better practice because we're not having to deal with changing the modifier all the time. And I don't know if this will even be perceptible. Weird. Never tried messing with integers like Java like that. Yeah, it's one of those things that really throws people. But yeah, okay. So we shoot super fast, and now if we change to, I don't know, red, you can see our speed. You can see our shooting speed slows down. And so now if we, I think it's no, it's X. Yeah, you can see it speeds up again. So if we change to red, it slows down, speeds up with blue. I do want to make it a little bit faster. So we'll say that the base is say 0.85. That's probably close enough. All right. So there's another thing too that we have. This 0.0f or 0.04 is sort of a magic number. So we're using that as the base cooldown. We probably want that as a constant. So we can say protected constant float. We'll say base cooldown. Oh, here's a quiz for the chat. Does anybody know what this is actually called? Like the formal name of this? Like the casing style? So the colored boxes are a power up kinda. Yeah. So I don't know if you saw the game that we're trying to emulate. Let me just put these together. Oops. Just put these here. So Omar, I was playing this is one of the entries for the Squarespace Jam, and I was playing it, and Omar asked me if I could remake this and kind of just explain how I would remake it. And so in this game, you can see that our projectiles, we have 3 green crystals. Our projectiles are massive. If I get like 3 blue ones, you can see the projectiles are much tinier and we shoot much faster. And so it's kind of the same mechanic. So the red ones give you the same amount of damage. And so this is kind of what we're emulating. But yeah, I like this idea. And so, yeah, we're just kind of emulating that to show how to do it. And so now you can see we have base cooldown. Now we don't have to remember, like, so suppose we were to change the base cooldown, right, to like 0.5 or something. Now we don't have to remember to change it in 2 places. We only have to change it in 1 place. But yeah, so this I believe is called camel case. But does anybody know what the casing style here is called? It's kind of funny, actually. But yeah, this should work. So yeah, we have the massive projectiles, and now if we have basically the same mechanic. So we fire much faster, and then, you know, now we do damage, but we fire slower. You know, same thing, fire faster, and then we have bigger projectiles, but we fire slower. Yeah, that's kind of how you do that. All right, I do need to go do something really quick, so I'll be right back in like 2 or 3 minutes. Apologies, did not expect this, but yeah, I'll be back in 2 or 3 minutes. All right, back. Okay. So it occurs to me that I said that wrong. This is actually Pascal case. So I think it's, you have camel case, which is lowercase first letter, camel case, and then you have Pascal case, which is uppercase first letter. And then, thank you. Yeah, and then the, with uppercase and underscores, it's called, I believe it's called roadkill case. Yeah, it's called roadkill case because you have the 2 tire tracks through it. So, yeah, I don't know. That's what I was getting at. It's just kind of funny. I think the name is funny. But yeah, so we have all of that. I think I don't know what we're missing. We have, okay, so we're missing the score, the UI, and also the health, and then I'm missing a couple things. Yeah, it's kind of, I think it's kind of funny. But yeah. Oh god, that enemy's way too fast. That needs to be like a speed 2.5 or something. Okay, so there's a couple things we can work on. There's the score, there's the taking damage and dying, then there's also the enemy spawning. I think we'll just worry about the enemy spawning, because that could get kind of interesting. So one of the things that we need to do with that is we need to have an actual object representing, let's say, the spawner. So in the game that we're trying to emulate, enemies like jump out of a hole in the ground. I don't know that I like that, just because I'd have to do some animation and I just don't want to. I kind of want them to come out of like holes in the walls or something. But then that, we'll just have them like spawn into existence. Just have them spawn into existence. I know what we'll do. I think it'll just be easier if we just have them pop into existence. So let me create a game object. This will be a spawner, because we need something to house the, call it a spawner component. And we'll make this look kind of fancy. So what we'll do is we will add a 3D object, let's say a sphere. Well, you know, as fancy as I can make it look for who I am, or for my art skills. So we'll create that. Then I believe that normally Unity materials, let's create green -2. I believe Unity materials can normally be transparent. I think that's normal, right? So if I change the transparency, do I have to have a special, it has to be render pipeline lit, URP lit, simple, metallic, opaque, transparent, aha. So yeah, you can add a transparency level to it. Okay, so we'll do that. Create that. And then I think we modified green too, right? I think that's what we modified. Yeah, okay. And then we'll do that. And then let us, oh geez, this is annoying. I think I can lock this. And now I can't select it. Great, yeah, that's what I want to do. So the hand icon here will just lock it so that I can no longer accidentally select parts of the map, because I don't ever want to do that again. And so what we'll do is we'll have this, and then we will have a smaller little thing inside. 0.5, 0.5, and 0.5. Ooh, that's interesting how the how that stacks. That's not what I expected that to do at all. So let's just put regular green inside of that. Okay, yeah, that's probably fine. So yeah, just keep those there. We're just gonna make this kind of pulse a little bit, but yeah, it might as well, yeah, it looks kind of interesting. Okay, just have that be a spawner. And then what we want to do is we want to create a new component for that. Usually whenever you want like a new behavior in Unity, you generally create a component for it. So call this spawner component. And so similar to the way that we did with the projectiles, we're going to have it instantiate an enemy. And similar to the way that we did it with the player, we're going to have it do that every once in a while. It kind of looks like the core of a slime, or like a core to a slime. Yeah, I don't know. I hope it looks kind of, well, I don't know. I don't know what to make it, I don't know. I don't know what to do with it. I'm just kind of going to make it like, you know, pulse a little bit, you know, just change the scale a little bit. I don't know, just so that there's at least some animation in the game. Yeah, it works. I agree. We'll just pretend that it's a green portal of some kind to the netherworld. I don't know. But we need a couple things. So actually, this is not where it was. In player controller, we have two things. The projectile prefab, so we're going to have an enemy prefab. And then we have the cooldown, so we're going to use the same cooldown sort of system. So in private void update, what we're going to want to do is we're going to say, just sort of the pseudocode for this. So we're going to say if, you know, time, say if time.time is greater than, you know, the spawn time, or the next spawn time. So another thing you should probably learn, or another thing that's good to learn how to do is to write pseudocode. So it doesn't have to actually compile, you can make it compile later. But, you know, if time.time greater than spawn time, then instantiate, you know, enemy prefab, instantiate the enemy prefab, and then we say that the next spawn time is equal to the time.time plus spawn, what is it? It'll just be spawn, not delay, interval. Yeah, be like spawn interval or something. So to make this compile, all we need to really do is we just need to add brackets around this, put brackets there, or the curly braces, and then we say instantiate, and instantiate will not work because we need a couple arguments for it. So we need to give it a position and rotation. So we'll say transform position, and quaternion.identity, skill or degree. Sorry, I don't know what you mean by skill or degree. I would say pseudocode's kind of like just a skill that is good to learn. At a certain point, yeah, I don't know what you mean by skill or degree, sorry. But we do know that time is a float, so we're going to need, if we're going to store spawn time, we're going to need that to be a float. So we'll say protected float next spawn time. And the enemy prefab is going to be a game object, so we'll say protected game object enemy prefab. And then this spawn interval is going to be a constant, so we can say protected constant float, like that. And then we want this to be assignable in the inspector, so we're going to say serialized field. And now this should compile and run. So if you're wondering, so the skill or degree, I'm going to assume you mean like a degree from like a university. So one thing I will tell you is that in my, like I do have a degree in computer science, but I will tell you that 90% of what I know, probably 95% of what I know, was not taught. Protected, a better way of doing it than private. So the reason that I use protected, like, instead of private, is because in my opinion, the private modifier violates a lot of object orientation. So in object orientation, you have, like, one of the design principles is called solid. So it stands for single responsibility principle, open closed, Liskov substitution principle, inversion of dependencies and dependency injection. I think that's right. Or no, inversion of control and dependency injection. So the open-closed principle means that things should be open for extension, but closed for modification. So whenever you create like a subclass, the problem is that private, it restricts you from accessing sort of the variables in a subclass. And so that makes it harder to extend things. So it sort of violates the open-closed principle in a way, because it makes it harder to extend stuff. One could argue that it's closed for modification, you know, that it's a expression of closed for modification, but I don't know, there's sort of a debate around it, but in my opinion, making things private just closes things for extension, so it sort of violates the solid principles of design, and that's why I don't do it, because I just prefer to be able to modify. If I need to mess with this in a subclass, I prefer to be able to do that. There's also a difference if you're using like Java or something, the protected modifier in Java works differently than it does in C#. C# actually has a good version of the protected modifier. It actually protects things as opposed to being stupid. In Java, if two things are in the same package, they can access protected members of each other, whereas in C#, that's not the case. C# actually, it works correctly, and it only lets you modify it in the subclasses. But yeah, that's my spiel on protected versus private, and that's why I use protected all the time. But again, there's certainly people who will argue that making everything private, keeps with the closed principle because you can't modify it in subclasses, but I don't know. It's just a disagreement. But that's for variables. Obviously for the Unity stuff, it actually doesn't matter. Yeah, I think this will work. So we can assign this in the inspector, and yeah, the spawn time, everything should just spawn at once. Yeah, that should be fine. But yeah, as far as my degree goes, most of the stuff I know I didn't learn in my degree program, but I ended up going to like an American school, so American colleges are generally pretty bad. They don't teach you a lot. They sort of waste your time. But anyway, in the spawner, we add the spawner component, and then what we want to do is in the enemy prefab, we want to put an enemy there. So now this should spawn an enemy every second. Is the if it works kind of thing for most, I guess. Yeah, I mean, in the other defense that I use is that I'm the only one who's ever going to mess with this, with this particular project. I'm the only one that's going to mess with it. If you're working on like a team, or if you're working for, like a company or on a team or stuff like that, usually they'll lay down standards just so that everyone's following them. And I'd say, you'd have to go with your boss's interpretation of the programming standards at that point. So, if I was on a team and they said, hey, this is how we do it, I'd be like, okay, fair enough. That seems offset. Well, they do teach you how to not think for yourself. Yeah, that's exactly right. In university, in American universities, they basically just say, here's what's on the test, please memorize it, my job depends on it. And, that's why you see a lot of people in my classes struggled, but I never really did, because I have the attitude of, I have the fortunate thing where I enjoy programming, and so I really, I like to teach myself, so I was ahead of my class most of the time. Like, I had been programming for many, many years before the first year of my degree program, and so, a lot of people had just started that year, so I was way ahead of them. So it worked out in my advantage. But just generally, they don't... Whoa. What happened? Why is that happening? That's very odd. Something is very wrong, but I actually kind of enjoy it. Huh. Needless to say, this should not be happening, but it's actually very interesting. I'm very curious. Oh, hey, Umbra. Just to be very clear, this is not supposed to happen, but it's just too interesting for me to not watch it. Things don't seem to be... Okay, so what's happening? It's actually quite interesting. Like, they're doing something, but I'm not entirely sure what. Like, I don't know why these two are congregating in those two different groups like that. I just don't know where they're going. Like, little friend, where are you going? It's just too funny. They're just like migrating. Oh, that's too funny. Oh my god. Okay. This is the most amusing thing you'll see all day. Oh my god. Okay. So actually, what are they actually doing? Did I move something that I wasn't supposed to move? Okay. No, really, what did I do wrong? So I'm spawning the enemy prefab, transformed at position and at quaternion.identity. Yes, that should be working. Is it not? Are there colliders on these? There are no colliders on those. No colliders on those. Is there an offset to this? Ah, these are offset. Ah, that's one issue. Then the other issue is the, I don't know if it's an issue per se, but you have an offset, which you shouldn't. And you have an offset, that's fine, and that's fine. Okay. So that should be closer to what we would expect. Okay, there we go. The other way it was definitely more interesting, but yeah, kind of like that. And yeah, we can hold this down, we can press, yeah, okay. So yeah, that's one issue in Unity, is if, so what happened was the graphics object here was offset from the actual, like, collision and everything. Why does it show that you still have a collision box? Or is that just the vertices that it's showing? I actually can't tell. You do have a collision box. I forgot why you had a collision box, but you do. Strange. Okay. Yeah, okay. Kind of like that. I mean, it is a little boring that, you know, they spawn kind of like this, but we can fix that. I think in the original they, let me see what the spawn pattern is in the other one, just to double check. Okay, so I think what happens in this is the game that we've been asked to sort of emulate. And I think they spawned from a random one. Okay, so they spawned from 2 there. So now what'll happen with the next spawn? So the 1 spawned there. Oh, they spawn in groups, okay. So yeah, they spawn, it seems like they spawn in groups, in like different little waves. Actually, are they spawning in waves? So wait, can I just have you two? No, okay, they're not. Yeah, they do seem to spawn at least partly in groups. Yeah, they spawn in groups, okay. So we can fix that. I gotta think about how, though. Trying to think of a way to do it that's not super complicated. Okay. So, what we can do is, okay, there's a couple ways that we could do this. So one of them is that we could have another component that sort of manages this, or we could have the spawners sort of figure this out amongst themselves. I'm going to opt for the other component way of doing it, but you could definitely have the spawners figure it out amongst themselves. So what we'll do is we'll have a spawner controller component, or have a spawner controller game object, and that'll just be an empty game object that just sits there, and its only job is to hold that, to hold the script. And then what we'll do, so we have a spawner controller component, spawner controller component. Yeah, I agree with you, Umbra. I think in this case it makes more sense. Like, it's easier for humans to, like, or not humans, but it's easier for us to, like, reason about it, because the, like, controller / manager structure so closely resembles, like, a corporate structure that we're very familiar with, and it just, like, it's just an easier way for us to think. But I mean, what you could do, right, is you could have all of the spawners sort of talk to each other, and then have one of them kind of take control. But I'm not going to do that. So first thing I want to do is I want to move this to a public void. We'll call it spawn. And then we'll give it a game object. We'll call this the prefab. What we'll do is we'll just move this logic into here. The reason that we want to do this instead of keeping it in the controller itself, or in the instead of putting this in the controller, even though it's only 1 line, it's very likely that this will change in the future, and then there might be some more stuff we need to do here, so it's good to keep it, you know, kind of on its own game object. we can actually just get rid of literally all of this. Unfortunately, yeah, this spawner component doesn't do very much right now, but it can do other stuff in the future, which it probably will. Anyway, we will need our favorite package, which is or namespace in this case, which is System Collections Generic. We'll create a protected list of, let's say, spawner components. Oops, not like that. It'll say that this is the spawner list. We need to create a list of these. In Awake, we can actually find all of the spawners very easily and say that spawners is equal to find objects of type. So we can say find me all of the spawner components in the world. And of course, this is an array, so we need. Alright. So the problem is that find objects of type returns a array. You can tell because of the brackets, and we want a list because lists are nicer to work with. So what we can do is we can use system, and we can use system.link. Link is an extremely powerful namespace that you should learn at some point, but it's also kind of an advanced thing. I think it stands for Language Integrated Query, and it lets you do some cool stuff, but in this case we get a special method from link that is toList. So for an array we can just say, hey, this is an array, actually want it to be a list, and now everything's fine. So it'll just take that array and convert it to a list. I think you could also do new list while as in link. Is that what you're talking about, Umbra? So yeah, you can also do this. I just like this because it's so much nicer. Oh yeah, link is like super crazy cool. So like if I don't know if you're aware, I don't know how aware you are of link, but like let's say you have a list of say, 1, 2, 3, and you want to double all of these. Like normally you do, for each, int, in, whatever. With link, yeah, link is super crazy. So let's say I wanted to like double all of these. What you can do, let's say I wanted, 2 or, 2, 4, and 6, right? What I could do with link is I could say, new list of int, say 1, 2, 3. What I can do is I can say select, and you can say, select each number such that it's equal to number times 2, toList. And now I've basically just done this just with a single statement. And so that's how link works, is what it says. So for each number in that list, give me the number times 2. And then maybe I want to select, only, or maybe I want only the ones that are divisible by 4. So, you could say, let's say 4, 5, 6. Now let's say I want only the ones that are divisible by 4, right? So that would be 8, 10, and 12. And so maybe I want only the ones divisible by 4, so I'd want 4, 8, and 12. Whoops. 4, 8, and 12. So what you can do is you can say where. You can say where the number, you can say where number modulus 4 is equal to 0. And so now what you can do is, what I've done is taken, 1, 2, 3, 4, 5, 6, doubled it, and then this will give me all the ones where it's equal to or divisible by 4. And so then, let's say we have, list, right? We can say list, and then rather than iterating through each one, we can just say list.forEach, and we can say debug.log. It doesn't like this, so the issue here is that you can't log a number, or so we can just say number, where we debug.log the number. And so now what we'll get, if this works, what we'll get is we'll get 4, 8, and 12 logged out for us. So let's say spawner component, spawner controller. But yeah, as you can see, we get 4, 8, and 12 there logged out. And this is a much cooler way of doing logic. It's like just super crazy. But the cool thing about link is that rather than doing like crazy for loops and things, you can actually sort of look at this logic and know exactly what it's going to do, rather than the 10 or 15 lines that it would take you in a for loop. And you can sort of guarantee that the logic is correct, right? So if someone says double something, well, we know that number times 2 is how you double it. You can say, give me only the ones divisible by 4. Well, that's number modulus 4 is equal to 0. And, it even lets you do crazier things like, in this case, we had an issue where we can't log each of these things because they're numbers. We can just say select each number and say, give me the number where number is a string. And it doesn't like that. Oh yeah, because it's not a list. To list. And now these are, so basically what we do is we convert from int. I could do list.forEach for that link. Oh, you can. Oh, okay. I forgot about that. You're right. You're right. This doesn't come. This comes from list. It doesn't come from link. You're right. I always forget that. Sorry. In Java, if you want to use this kind of syntax, like this for each syntax, you have to use streams. And so my brain just conflates streams with link. So yeah, if you're aware of streams in Java, link is basically just streams, and it's so much nicer. Love it so much. But yeah, it's so powerful. And yeah, if you should show you oh, I don't know Java. Yeah, let me just show you what I was doing for a different project. And you can see, oh, this is the wrong one though. Let me open the other one. We will have to deal with this controller stuff next time. I know, so you know the web technologies. Oh, so you know like LAMP stuff, plus C# and Lua. Okay. Yeah, I think we know basically the same languages, so I have familiarity. I have familiarity with CSS and HTML, though I suck at both. PHP, PHP I personally hate with a passion. But no, I understand. I can't do PHP. I've looked at it a little bit, but yeah, it's just not a language for me. Like people always taught me JavaScript, so I'm like, I don't need to learn PHP. SQL, yeah, I've done that. Lua, I have like a very passing familiarity with. But yeah, I'm trying to find the crazy stuff that you can do with link. Might be in here. No, of course, this is the only one that doesn't have crazy stuff in it. Where did I do some of the crazy stuff? Game Manager? No, of course not. Where is all the crazy nonsense with link? Oh, it's probably in here. Yeah, you can do some pretty crazy stuff with link. I can't find it though. So in player like .trainable skills, we can compute a union, we can do toList. Yeah, you can do stuff like this. So for instance, like this computes like the learnable skills for a player. And so you have just all this nonsense. And so what it does is you say, so go to the skill list, get all the skills where the player meets the requirements. Then you take all the skills that are not in, basically you take all the skills where, I don't remember all skills. Oh yeah, you take all the skills. So from the global list of skills, you take all the ones where we meet the requirements, and then you take all the skills where the ones that we know, like we currently don't know them, and also there's no reason to exclude them. And then you say, if we know, so that makes managing a list easier. Yeah, basically. It's not always lists though. You can do dictionaries and basically everything else. It's really the concept. It's not. I'm trying to think about it. I'm trying to think of a good way to explain it. Streams basically. Yeah, it's definitely worth learning. Like it will. I'll put it this way: you will never use, if you know link, you'll never use a for each loop again because there's no reason to. they're like a for each loop is just strictly weaker than LINQ itself. Also, in LINQ, you don't get closure issues because I've been making my own functions to manage them. Yeah, LINQ is super powerful, but the idea, it's not really a list of data; it's a stream of data, and so it lets you do transforms that are much easier to understand later. Like now, you can tell very easily what this does. You can say, give me all the global skills where the player meets the requirements, where the player's the skills that we've already learned doesn't have that skill, and it's not excluded. And also, if we have a keystone skill, it's not a keystone skill, and then finally transform the skill to its own name, and then return that list. And so rather than going, for each skill in skills, filter out these, filter out those. Yeah, you have that sort of thing. There's also like min and max. So if you have like a new list of integers, 1, 2, and 3, you can say dot max, dot min, you can compute the sum. You can, oh yeah, I know a good place. In the details, I do it somewhat. No, so list and details. In details, yeah, in here. I use some of it to manage, yeah, so what I do here is that I collect, or actually, what's a good one? Yeah, so here, in the skills that help kind of thing. So what I do is I get the event, I get the skills, like the list of skills that'll help. Then what we do is we go for each skill, and then we say, hey, put a bullet point in front of the name. And then if these skills that we've learned contains this, then put this learned after it as well. And then this aggregate, what it does is it will join this list of strings, and it will put a new line between each one. And so you can just do all sorts of crazy things with this. Same thing with like, trying to think of better ones. There's like enumerable. Enumerable, I think, comes from LINQ. So there's like this repeat sort of function. It's really crazy what you can do with it. Like it'll definitely take your programming to the next level. And the only reason we need to do a for each here is because Unity is weird with how it treats its transforms. But this is mainly just to get the iterator. Yeah, it's pretty crazy. But yeah, this generates a bunch of, well actually, let me just run it and show you. Let me just run it and show you what it generates. So yeah, basically we have, this list of backgrounds, and again, it generates, this, this text on the right. Let me think about stuff here. So right here, this is all done with LINQ. So like this arena event, still trying to figure out the blank, never really learned what it means. So it creates a lambda, and I can go over that in just a second. Yeah, in this case, like in the event, it iterates through all the stats, but this isn't like typed out. This isn't typed out with a for each loop. Like none of this uses a for each loop. It all uses LINQ. So the lambda, the arrow, all that does. Where's a good example of that? It creates an anonymous function basically. So yeah, it's an anonymous function. So in the for each case, it's a good example. So we can say, I don't know, say skill list.all and .for each. So this takes an action, or the argument for this is an action that takes skill, it takes a type skill. And so what that means is that if you, I'm trying to think of how to explain it. Can we just do new action actually? I think you can, right? No, you can't, okay. I'm trying to think of a good way to show it. So like in the case of, okay, let's create a public void log skill, I guess. Say, skill, skill. And let's say debug .log debug. Oh, do we not have Unity Engine in here? We don't. All right. Hang on. Using Unity Engine. Yeah, the arrow itself though. So you can say debug.log. Let's say skill.name. Damn it. Can't type right now. Skill.name. So basically you have a function, right? It's a void function, or it returns void, and it takes a skill as an argument. So in the skill list.all, which is just a list of all the skills, it's just type list of skill. We can say for each. And then we have an action that takes a skill. So an action is just a void function. So we could say for each log skill, and because the void function that takes a skill as an argument, it meets the criteria for action. But what we could also do, so in the case of log skill, if we just take away the, say we take away the name and everything, then we just have skill, and then we take away all of this, and we put an arrow over here, and then we don't need to give it the type because it already knows it, and that's your lambda function for a skill, and so we can just copy paste that into here, and that's what the lambda does. That's what the arrow basically does, is it just replaces all the other nonsense that we don't need. And so yeah, in this case, if we had, you know, like a skill, then an arrow, then debug.log, skill.name. Basically, in this case, it just creates an anonymous function. So it creates a function that returns nothing, and we know that because debug.log returns nothing. And we don't need the name, we don't need the return type because we already know it, and we don't need to say, you know, skill because it already knows that this is supposed to be a skill. And so we don't need any of that. We can just get rid of all of it, and that's what the arrow does in that case. But yeah, just an anonymous function. You can also do it for other stuff. So in the case, I think I do it for a couple things. Oh yeah, in this case, max training points. This is the same thing as, this is called an expression defined member. It's the same thing as defining a constant. But yeah, it's basically, yeah, that's what it does. It's just a fancy way of creating a function with no name. It's like an anonymous function in Lua, or I'm sure you have like anonymous functions in PHP as well. I don't know how they work, but I think you have them. But yeah, that's all it does. But you can also use it if you're referencing a constant. So in this case, this int, it's basically the same thing as doing like public int get max, you know, get max training, or get training points max, return 5. So this is just shorthand for this. And so yeah, it's much nicer. So you can use it in the case of like trainable skills. So like each time I want to create a new list, I want to basically create a list of skills the player already has, plus the ones that they've learned this turn, and those are the ones that are trainable. Or sorry, I think that's right. Actually, I don't remember this. Oh yeah, right, okay, because the skills that a player trains are the ones that they know, plus the one that they learn this turn. So we can just say, you know, we want a new list of that. And the reason that we want to create a new list here is just so that we can mutate it with union, and then we just return it. So it's basically returning the union of two lists. So yeah, that's what all that does. But yeah, I highly recommend Link. It really does change the way that you think about programming. It's really fun. But anyway, we're a little bit over time, so thank you guys for joining me. Tomorrow I'll be back at the same time at 11 a.m. Central, that's US, Texas, and we'll work a little bit more on the stuff that we were working on before. And we'll get the spawning stuff working and all that. Actually, you know what, no. Since it's so late for Omar, what I'll do is I'll come back at 10 US, Texas. So yeah, 10 a.m. US, Texas tomorrow. Anyway, I'll also probably do some streaming later. Yeah, I'll stream later at 3 in the afternoon for me, 2 hours from now. We'll play some more games from the Squarespace Jam. Anyway, thank you guys for watching, and I'll see you.